Good morning everyone. I am Dr. Kanika Mandal, Assistant Professor, Department of Mathematics, Sri Ramakrishna Sharada Vidya Mahabir, under University of Bardwan, West Bengal. Today we will discuss about sequence of functions. Now we are familiar with sequence of numbers, especially sequence of real numbers. What is sequence of real numbers? Sequence of real numbers, that is a function that goes from set of all natural number to set of all real number. Now here domain is set of all natural number and codomain is set of all real number. If codomain is set of all complex number, then it will be sequence of complex numbers. Whenever codomain is vectors, set of vectors, then this is sequence of vectors. Whenever codomain is matrices, then it will be sequence of matrices. In this way, sequence of functions. But functions should be defined on specific domain D. Otherwise, we cannot move further. Let D subset of R and N belongs to N. Let Fn such that D to R be a function. Then Fn within second bracket, this is called sequence of functions on D to R. After that, we consider an example, very renowned function fnx equals to x to the power n, where x belongs to domain D. What is that? Closed interval 0, 1. Now, if you draw the graph, I am going through the PPT. Here if you see the graph of the function fnx equals to x to the power n, now we are seeing that for n equals to 1, this is the function y equals to x, and then y equals to x square, then y equals to x cube, and so on. That means whenever n goes to infinity, then fnx converges to another function, and that function depends on the variable x. So depending on this convergence property, we will define two types of convergence. One is pointwise convergent. What is pointwise convergent? Pointwise convergent means for each x belongs to D, fnx converges. That means for the function fnx equals to x to the power n, while what will be the value of fx? Fx will be 0 for x belongs to closed 0 open 1, and 1 for x equals to 1. Now if we go through the epsilon definition of the limit, then for pointwise convergent, for every epsilon greater than 0, we will have a positive integer m such that n greater equals to m implies modulus of fnx minus fx less than epsilon. Now this m obviously depends on x as well as epsilon. Now if we keep epsilon fixed and vary x, then we will have a set of values of m x epsilon. If this set of values has a upper bound, what is the upper bound? That means that number does not exist this set of values. Then n greater equals to m implies modulus of fnx minus fx less than epsilon. In such a case, we say fn converges uniformly f on D. So what is the difference between pointwise convergent and uniformly convergent? We will get the geometric interpretation. For pointwise convergent, it has been seen that for n greater equals to m, f of n x0 intersects the vertical line y equals to x0 inside the interval f x0 minus epsilon and f of x0 plus epsilon. But for the uniformly convergent, fnx totally lies inside the strip fx minus epsilon and fx plus epsilon. So in the next class, we will consider another various types of examples, and we will check whether those functions are uniformly convergent or pointwise convergent. Thank you.